I think it's time to get a little more familiar with the Freedom K64 components. And we have an Ethernet connector here, which allows us to connect up to the Ethernet with an RJ45. We also have where our micro USB connector goes into here, which is our DAP link connector here. Down here, we actually have an accelerometer and magnetometer, which allows us to use it as a compass or just to see how fast things are changing in the X, Y, Z directions. And we also have the ability to add on here, as it says, an RF module, and that can be added on here. We also have a place over here where you can add a Bluetooth module if you want for further expansion. We also have one last thing here, a micro SD connector where we can hook up a micro SD card to actually store lots of data. But the three things that are more important to us right now is SW3, which is the left push button, SW2, which is the right push button, and our RGB LED here that we're going to be using in this lab. Now you notice up here, this is the microcontroller itself, the MK64FN1 M0VLL12, and this is the microcontroller that is used on the Freedom K64. This is SW3 here, this is SW2 here, and it's got a pull-up resistor here to 3.3 volts, and it's got a capacitor here of 0.1 microfarads to make sure that it's not going to have any problems with bouncing. And SW3, this one here is connected to PTA4, which we're going to see shortly in the video. And this one here is connected to PTC6 SW2, and we're going to need that information when we start programming for this particular lab. Down at the bottom here, we can also see our RGB LEDs, port B pin 22, port B pin 21, which is our red and our blue, and PTE 26, which is our green. You'll notice here that the resistor sizes are a little different. We got 270 here and 270 here. But we've got 430 here on the red because you're going to find it's a lot easier to generate a red glow on the red LED. Now this is Lab 4 called Using MCUXpresso Config Tools, and it's 12 pages. And there's a lot of things that could go wrong. And that's why I'm taking you through this in the video to make sure that each of the steps that are required are done properly. And we're going to start by creating a new blank project with default settings, including semi-host. And we're going to call it this name here. Now what I'm going to do is I'm going to use MCUXpresso, and I'm going to work down through here. And if you want to follow along with the lab, then you'll see that everything is done in the same sequences as in the lab. By creating a brand new project, and we're just going to click on the Freedom K64, and we're going to have to make sure we change the name to the one that's supposed to be here. And it basically says LAB4, 2 buttons, which are SW2 and SW3, and 1 LED, which is going to be a red LED, and IRQ for interrupt service routine. To finish this off, we're just going to click on semi-host and say finish, and it's going to create our project for us. At this time, we're at page 3 of 12, right at the bottom. And what it says here is to go up here, click on this, go down to MCUXpresso Configure Tools, and open Tools Overview. Oh, you'll notice in here it says you have to make sure you've enabled certain things here, such as board init buttons. And so we're just going to click here, wait for it to change. And it also says we have to have board init LEDs, which is this guy. And we should have board init debug UART pins, which I think is already done. So what we have to have is all of these pins here set up. And at that point, we can actually just say close and update code and say OK. And that part of the project is done. And you'll notice we've got a MEX file here. Now what we can do is go back up here and click on this icon, or we can go back in. And what it says here is we want to go and click on board init LEDs pin. So let's go here, and we should see exactly what we've got here. Now we're basically up to part 6. So we want to go back here again, and we want to now go to board init button pins. And we should see this coming up, and we can always update code if we're not sure that it's updated, just to be sure. And it's going to drop us back to here. Now at this point it says to go to the clocks, so we can just double click here to get to clocks and make sure everything is okay according to what it says there. Now once we're done at this point, we can also go back to here, supposed to check on here, which is our peripherals. And so if we go here, we can double click on our peripherals here, and we'll see that these are the things that it's mentioning in the lab. And as we saw before, The nested vector interrupt controller is the only thing that's picked. But what we have to do is we have to now start configuring GPIO port A and GPIO port C. To configure GPIO A, what we do is we click here, and it's going to bring up this requester. And we're going to choose the last one here because these ones have warning symbols on them. So we're just going to click here and say OK. And what we're going to do is we're going to go up here and enable interrupt request. And we're also going to go down here to enable custom handler. Now notice it's got GPIO IRQ handler, so we're going to copy that to start. And when we first click here, it's going to complain about this. But if we put in here SW3 underscore, and then paste in the rest of it, it's going to accept that. Now that we've got that, we can do the GPIO C. We're going to click here. And it's going to come up here. And of all of these, this is the one that we want here, the one that doesn't have any kind of warning message. And again, what we're going to come up here and do is click on Enable Interrupt Request. And again, we're going to go down here to the handler here, copy that, and we're going to put in custom handler, and we're going to type in here SW2 underscore, and then paste in the rest, and everything is good. And make sure that we update everything. Notice this is highlighted now, so we can click here, update, and we update everything that's there. And we should be pretty much ready to go from this point on to the next step. Now, it's very important at this step to make sure everything is updated, so we can just go back here and make sure that there's nothing here that shows that isn't updated. Everything seems fine, so we should be able to go on to the next step. So let's close here, and we'll just update just to be sure. Now at this part of the procedure, we're supposed to add 2 interrupt service routines, one for SW2 and one for SW3. So what we're going to do is we're just going to copy everything as it is, and we're going to paste it into our code. Now, the interrupt service routines have to be placed before main and between the include section, and that's what I've done here. You'll also notice that I've got IRQ service routines written here as a heading for this section. So at this point, what we have to do is put in side or main, LED red off, and 3 printf statements, one that says LAB4 part 3 and your name, not mine. Press SW2, which is our right push button to turn the red LED on, and press SW3, which is left push button to turn it off. All we have to do now is just hit the debug. Let's switch to console and hit our run button, and we're going to see these messages coming up. Now, if you hit the right mouse push button, which is SW2, at this point you should see the red LED coming on, and if you push the left push button, you should see the red LED going off. If you don't, then I would check to make sure updated everything, and you should find that it will indeed work. Now let's take a look at the 2 push buttons, SW3, which is our leftmost push button, and SW2, which is our rightmost push button. The way this works is if the switch isn't pressed, this pull-up resistor is going to make sure that there's 3.3 volts here or 1 in binary on port A, pin 4. Same thing on SW2. If it's not pressed, we're going to get a 1 on port C, pin 6. If we press this, what's going to happen is it's going to have ground all the way across here to PTA4. And if we push this one down, it's going to have ground all the way out to PTC6, which means 0 on these pins. So not pressed, you get 3.3 or 1. Pressed, you're going to get 0 volts or 0. When we press or release SW3, it's going to make a change at address 400F010 at port A, pin 4. Now if we press or release SW2 here, it's going to make a change at address 400F090. When it's pressed, we're going to see a 0. When it's released, we're going to see a 1. At this point, I've got in the memory browser the address here for the port A data input register, which is where SW3 is connected. Also here, I'm about to execute the board init boot pins, and when I do, by just stepping over, we can see that this number is changed here. Now this is the one for SW3 here. This one down here is the address for SW2. So SW3 in here. So what I'm going to do is I'm going to go here first of all, and I'm going to double click on that, and I'm going to hit a 0. And if you see 0, what it does is it forces it to read this again to get the 4. But what I'm going to do at this point is I'm going to hold down SW2, which is a right push button. And if I hit 0, I can see that that has gone to 0, which means it knows that it's pressed. If I go here again and put 0 in this time, when it's released, it's going to come up with a 1 here. Same thing here with this one here. If I double click here and put a 0 in, then these numbers stay the same. But if I hold down SW3 now, and I put in a 0, we can see that this bit here, which is the bit for SW3, is now changed to a 0. If I release it here and put a 0, then you can see that it's come back. So SW3 is going to manipulate this bit, and SW2 is going to manipulate this bit over here as the push buttons are pressed and released. Now, if we go to pins here, it shows SW2 and SW3 as our identifiers. It shows pin 6 and pin 4, which we just looked at. And it also has here interrupt on the falling edge, which means when we press the push button, it's going to actually generate an interrupt. So while this main line is running and it's sitting in an infinite loop here, at some point you're going to hit SW2, which is our right push button. What it's going to do is go up to this handler here. And the first thing it's going to do is clear the flag so it doesn't interrupt itself again. It's going to turn on the red LED. It's going to go back to the loop here. Eventually you're going to hit SW3, the left push button. It's going to go up to this handler here. It's going to clear the interrupt here and then turn off the red LED and then continue on in the loop. And that's basically how the code works here.